Good afternoon. So what I'm going to present is a sort of story of a project where we combined different materials to reach a quite challenging result. So this is the title that we have decided to put: when overcoming the engineering challenge of combining fiberglass hull with an aluminium alloy superstructure in a 50-meter build called VICA, and what a successful fusion of diverse materials could mean for the future of yacht construction. When we start the project, we try to write down a mission, and we wanted to put all the up-to-date market demands on a yacht that should be below 500 gross tonnage and with an efficient hull, a proven quality, but also the flexibility to adapt a different design, especially in the upper part. So we started with very simple steps. One is to sketch down the desired boat. The second is to check what would our range provided at that time. We are speaking about 2011. And define the production schedule in order to check the optimization and the time saving. This is the wish list that at the end was the must list. As you will see in the GA, we designed the yacht without compromises, with all the possible feature that could be fitted on a 50-meter. But rather than read, maybe it's better to see the GA, where we have 1, 2, 3 side platform, a beach and or a garage tender able to accommodate a large tender. Then we have a private owner cabin with terrace, a large salon, and on the upper part, a large veranda, plus on the floor of the sun deck, the possibility for an helicopter landing area. So when we start and the first loop of basic design, the result was well, we start first of all from what the range of Benetti provided at the time. Just a quick check of the main characteristics, like this one that is crystal, that has been delivered in five yachts, plus vision that is in fiberglass, and we made the 17 yachts with this series, and Imagination 47, that is a semi-displacement full alloy yacht, still under 500 gross tonnage, but with a maximum speed well above the standard, and a steel and aluminium custom yacht. All these 4 projects are below 500 gross tonnage, are certified by MCA, are certified by ABS. But what we were looking for is something different. And even the enormous data bank of technical parameters and other features from the proven yachts provided a good base to start the design. The first results on the layout that I showed you before went over the expectation, especially in terms of weight and volume. And so we were above 500 gross tonnage. And you know that MCA above 500 gross tonnage ask for structural fire protection and enhanced fire structure protection. So we start different loops to reduce the weight and reduce the gross tonnage, keeping the size 50 meter by 9 as a minimum to fit all the features that I listed before. So the the key point was the reduction of hull and superstructure weight, and that will be to be reduced about 33%. We thought that aluminium was and is a good material to accommodate any possible modification or a different design. But being a displacement yacht, we consider not applicable for the hull construction. So we have from one end the heavy solution of the steel, and from the other end the possibility to use fiberglass. Again, this is just to mention that we tried to minimize the weight with steel, but was not possible. Otherwise, we will against the quality of sides and so on. We check if the molds that we had for Crystal and Vision were applicable, maybe modified for a 50-meter yacht, but was not possible. And the good was that the good feedback on Imagination, that is a fast boat solicited by the different and high-frequency loads, was good for the construction of the superstructure. So this was the beginning of the challenge that a large fiberglass hull can be fitted under a large superstructure in aluminium. So we designed a complete brand new hull, fully tested. Just to mention that the weight saving between the fiberglass and the hull help itself by 12% in the resistance reduction. And then other improvements have been done on the bulbous bow and the stern lines modification. We made an extensive finite element analysis on different fields I'll show you later. And at the same time, we start the design of a big mold, because we are speaking about 50 meter by 9 meter molded hull, with important feature of a safe area to work, the strength of enough to support the weight of the mold, and then optimize the production to reduce the time. The coupling between the fiberglass and the aluminium alloy has been studied, taking into account all the possible cases. So varying with the position on the junction between the superstructure and hull, we studied the different type of connection. Class imposed the use of bolts. So, and on the other hand, the bonding was not compatible with the timing of coupling between superstructure and hull. So we progress with schematic finite element models of each junction, applying also the mechanical characteristics of the different materials. The blue one is the aluminium, and the green and pallor blue are the characteristic of strain and stress of fiberglass. The same is for the thermal expansion coefficient, that on aluminium alloy is isotropic, while on fiberglass varies with the direction. And on that model, we applied the different loads, the thermal loads, the loads induced by wave bending moment and shear, and then we also perform frequency response analysis. The worst case we found was the junction at the main deck corridor in the lightest yacht condition in sagging. And so the most severe loads on the bolting coupling has been applied to the detail, and also on the and also the tightening of the bolts has been adopted according to UNI standards. This is an example of what we have done from global, local, and statical and dynamic response. So the model has been fitted with all the inertia and the masses from the main and also minor components. And at the same time, we, having the experience of large fiberglass boats, we had also the possibility to introduce, let me say, reliable value of the structural damping that is difficult to predict theoretically. So this set of analysis provided good results in terms of vibration response. And so we progress with the final design and detail, and we go into production. At the same time, as mentioned before, we designed the large mold, the biggest ever built in our company. And we followed, of course, the most severe rules for the safety of personnel. And for instance, that one is the passerelle that is being also tested with the finite element models. And we studied also the way how to embark bulkheads and large part of fiberglass, because also the shed was tight. And so this, and then last but not least, we studied the way to take out the hull from the mold, leaving the hull supported by the central cradle. So the cradle you see there was fitted with rollers and moved without any problem, because it was the only one supporting the whole weight of the hull. Just a few pictures of this big mold. This is when the person was assembling the mold. An example of the importance we made on the safety and strength of the mold itself. And then we started the production. So if you look at the picture and you make a proportion between the man and the sides, you can imagine how big was and is the hull of this yacht. At the same time, we were building the aluminium superstructure with time saving. Then just an example of key points of junction. This is the main corridor where at the main foyer entrance. This is the bow. That one is at the fashion plate level, and that one is at the main staircase. As you can see, while the superstructure was bare aluminium, the hull was already prepared to receive a slight filler application to complete the job. Then I haven't put in the presentation, but of course we fitted all the plants, all the systems according to rules and yard standard. And this is the day when we moved from the shed, and I titled not only a launching, because during this maneuvering we also applied strain gauges to check some key points at the coupling. And as you can see, the trolley is just under the keel, and nothing has been measured in terms of deformation or stress. So very negligible, let me say. So at the end, we made the sea trials successfully. So I'm very proud to show these numbers, because we started with something around 500 tonnage, and we arrived at a full displacement of 420. We were a little bit conservative in the power prediction, but a confirmation that the hull is really efficient are the 16.7 knots with two 1,000 kilowatt engines. And in terms of noise and vibration, we made most of the measurements at full power and full speed with excellent results. So, and this allow us to say that there was margin also for improving. This is the story of Vika and how we arrive at this result. Just a couple of other words on what the research and development department of Azimut Benetti Group is doing. So is a Benetti Mediterraneo, is a brand new yacht, is 116 feet displacement, where the carbon fiber has been used for the complete construction of superstructure. And the result, we have not launched, but we are nearly there. And the result so far is, I show you in the GA that large windows was possible. The superstructure are lighter than traditional GRP, so the stability is enhanced. And in other words, the global comfort of the yacht is improved. I hope that next year or in other events we will present, as we did with Vika, the picture of the boat sailing. And this is the way how we think that the combination of different materials can improve the product. And thank you.